Good morning, good afternoon, depending on where you're logging in from. Thank you for joining us for today's webinar, Assessing the Early Impacts of the Clean Mile Standard on California Ride-Hailing Drivers. Before I kick things off, I want to go over a few logistics to begin with. For any technical issues or questions during the webinar, you can email Natalie Reevy at natalie.reevy@arb.ca.gov. She will put her email in the QA section for your reference now in case you need to reach her for any technical problems assessing the Zoom webinar. Hopefully we don't have technical issues, but that's for help. I also want to let you know that we are recording the webinar. We will let you know via email when the recording and the presentation from today are available on the CARB Clean Mile Standard website in the next few weeks. Natalie will drop a link to our website in the chat section as well. Finally, we are taking questions via the QA feature at the bottom of your Zoom screen, as well as using the raise hand feature and allowing you to unmute to directly ask your question. We will be answering the questions after all of our guests finish presenting their slides, but feel free to submit your questions in the QA box during the presentation while it's fresh in your mind. Okay, now that we have gone through event logistics, I'm excited to welcome our researchers from UC Davis, who will share valuable insights from their study exploring the use of zero-emission vehicles by ride-hailing drivers in the context of the Clean Mile Standard. Their final research report is now posted to our CARB website, and we've put that link in the QA box. As California continues to aggressively address climate change and air quality challenges to protect public health, the board adopted the Clean Mile Standard in 2021. Companies that provide ride-hailing services through the online platform in California are required to comply with the standard that has a target of 90% electric ride-hailing miles by 2030. These services are operated by transportation network companies, or TNCs, such as Uber and Lyft. Today's webinar will explore the research findings on opportunities and challenges ride-hailing drivers face with electric vehicles and how many TNC drivers use this vehicle technology. The research team will share insights on current driver trends, key barriers identified, and policy recommendations. This research was important for CARB to fund such that both our agency and the California Public Utilities Commission can learn about ride-hailing electrification barriers as we continue to implement the Clean Mile Standard. This is the new type of regulation we want to track its progress. Okay, now I'm pleased to introduce our speakers for today. Dr. Giovanni Circella is the director of the Three Revolutions Future Mobility Program at UC Davis, a professor of mobility in the Department of Geography of Ghent University, and the head of the Master School of the European Institute of Innovation and Technology Urban Mobility. Dr. Youngsung Lee is the co-director of the Three Revolutions Future Mobility Program and assistant research professor at UC Davis. Dr. Xietian Johansen is a postdoctoral associate at George Washington University and the National Institute of Standards and Technology. And James Giller is a PhD candidate in the Transportation Technology and Policy Program and the Three Revolutions Future Mobility Program at UC Davis. Giovanni, the microphone is now yours to begin the presentation.
Thank you so much, Joshua, for the nice introduction, and thank you all for being with us today. Good morning, everybody, or good afternoon, good evening, depending where you are connected. And it's a pleasure to be here together today to give an overview about this project that we have developed. We have carried out with our research team at the University of California, Davis, in very close collaboration with the California Resources Board and the California Public Utility Commission, and also I would say with a great support also from TNC companies that were very helpful also in helping us survey and collect information from their drivers. So to jumpstart this presentation, sorry, James, can we go back to the previous slide? I would like to acknowledge, first of all, that today I will be accompanied in this presentation by three other fantastic colleagues that were part of our research team at the University of California, Davis, as Joshua has already introduced at the beginning of the webinar. But also want to mention that for this study, we could count on the contribution of many other colleagues that were not listing here and are not part of this seminar. but they also were fundamental in the research and in the support, and really want to thank all of them. In particular, one of them, Professor Patrick Loa, was very essential to many of the activities of the project, and I really want to thank him also for the great contribution, together with many other colleagues that were contributing to our research. Now, if you go to the next slide. So let's start our presentation giving a little bit of the background of the research of why we did this project. As Joshua mentioned, next slide please, the climate standard is a policy framework that has been adopted in California with the goal to mitigate the environmental impacts of ride-hailing services. And as part of the climate standard framework, annual targets are established to, first of all, reduce greenhouse gas emission per passenger mile travel, and the second thing to lead to an increase in the percentage of vehicle miles traveled delivered by zero-emission vehicles. And the targets become more stringent over time. And so what we did with this project, next slide please, we wanted to work together with the California Resources Board and with the California Public Utility Commission to support the evaluation of the early impacts of the climate standards regulation in California on rideshare drivers, help shape recommendations on how to improve the climate standards program, and in particular, identify barriers and opportunities for drivers to transition to zero-emission vehicles, and also establish some baseline conditions and help monitor the impacts of the CMS on drivers, particularly for those that are from equity priority communities, in line also with the Senate bill that was instituting the climate standards that also requires specific action to monitor the impacts also for drivers that belong to certain community, to certain conditions, and try to help mitigate these impacts over time. And so if you go to the next slide, let's get a little bit into our project and the structure of the project. And first of all, let's talk about the data collection that we carried out as part of our research project. So I would like to get into the details here of our study design. So in this study, we had a pretty ambitious data collection plan that consisted of multiple surveys of California drivers that work with the two major transportation network companies in California, so Lyft and Uber. And what we wanted to do was to start building this data collection over time with a first round of data collection that was launched in November 2023 with a smaller pilot. This also helped evaluate a number of things, including also a right methodology, response rate, level of incentives to use, and so on. And this evolved into the full data collection that lasts until about June 2024. We collected initial samples in this data collection from both large TNCs in California, and this was constituting a large body of data that we could analyze already from the first year, while at the same time we plan to collect the second round of data collection that happened about a year later. So in early 2025, we launched the second round of data collection. This second wave was carried out between February and June 2025. And for this case, we could recruit both respondents that were already part of the first round of data collection in a true longitudinal sample approach, but also we had additional respondents that were recruited with another sample that was recruited with one TNC. You will notice here that two TNCs participated in the first data collection. In the second one, we could count only on one of them to recruit the additional drivers because of some delays that they were in the process with the agreements with the TNCs and internal approval in the TNCs. Additional respondents were only recruited with one of the two TNCs in the data collection number 2. Now, let's get to the next slide, because here's really some of the ambition of this project. For this study, we carried out a data collection using a stratified random sampling approach. This was pretty ambitious because we wanted to collect data from drivers, but also we wanted to have a good ability to generalize the results to the body of drivers in California for ride-hailing services. And for that, we wanted to get a good coverage by geography, but also with the type of drivers that serve ride-hailing services. And to do that, we use 3 strata in our stratified random sampling approach, and we use the region where the drivers were providing most of the rides. And so this includes the Bay Area, the Sacramento area, the San Diego area, the Southern California region, so around the Los Angeles fundamentally we follow the boundaries of the MPOs, the Metropolitan Planning Organizations in California. And then the fifth area is the rest of California. So the lower density areas in the extreme north of California or in the central part of California, including the coastal area, the Central Valley, and the mountain region. The second stratum that we could use for the stratified random sampling was the tenure as a ride-hailing driver, measured in years. And this was to measure, to include in the sample a control how many drivers we had in our sample that have been driving as a ride-hailing driver only for a short time, so less than 2 years on the platform. Those have been for quite a bit of time, between 2 and 5.5 years. And those have been for a very long time on the platform, 5.5 year plus. And this is really to mirror the very different behaviors that we have also when it comes to optimizing driving decision and vehicle acquisition decisions, depending also on the time scale and how long the drivers have been on the platform, how much experience they have to be on the platform, but also what is their horizon in terms of tenure on the platform. And then the third dimension that was very important is also how much a driver drives. And that is very important because, it's very different behavior if you consider very frequent drivers that do this, in many cases, a full-time job, like more than 25 hours a week. So these are very, very intense driving activity for intense drivers. And other drivers that might have some middle number of hours, between 10 and 25 hours, but also other drivers that are only drivers that do some supplemental driving very often in addition to another job, for example, and they drive less than 10 hours a week, for example, because they have other activities and they only do this as a little activity on the side. You can imagine also that this implies very big differences when it comes to the dynamics about vehicle acquisition, cost optimization, and all the decisions associated about driving a vehicle or eventually switching to electric vehicles or changing the vehicle they drive on the platform. I would like to move to the next slide, but with that, I would like to pass it to one of our team members. James Giller has been a fantastic team member, a PhD student in our university, University of California, Davis, almost done with his research, has been really running a lot of this project as his primary interest as part of his PhD. And he will drive us also into more details into the data collection, considering in particular that on top of the stratified random sampling, we could have also the ability also to reweight the data to reduce deviation from representativeness of the population of drivers in California, and so even better mirror the population of drivers in California. Before I pass to James, I want to mention one thing. We are very proud of this project, and we are very proud we could set this up with this approach with CARB, CPUC, and all the partners. To our knowledge, this is the most rigorous scientific data collection ever done on the population of ride-hailing drivers in any scientific study. Nobody, to our knowledge, has attempted to do something similar, to do a stratified random sampling, to do a lot of testing with the big two TNCs in California, to really also understand the population characteristics of these drivers, to use targets from the population of drivers to reweight the data. And so this is also a very, very important value from this project, on which then this gives also bigger value to the analysis for the project and also ability to generalize the results for the population of ride-hailing drivers. With this, I would like to pass it to James, and James, please take it from here.
Thank you, Giovanni. So with that general overview of the survey data collection, I would now like to provide some further details, starting with our recruitment process. So our research team at UC Davis collaborated with Lyft and Uber to recruit drivers by email to take an online survey that was hosted on the Qualtrics platform. So first, we worked with the TNCs to develop the sampling plan and to help them implement it on their internal databases of drivers. Lyft and Uber then sent invitations to the random sample of drivers for the first survey wave. Our research team then securely accessed the online survey responses from Qualtrics, and some drivers voluntarily provided their email addresses and agreed to be recontacted to participate in the second wave of the survey. Then in the second wave, we directly sent email invitations to this longitudinal sample of drivers to complement the new samples recruited by the TNCs in the same way as the first wave. Then to improve the extent to which the sample data that we collected were representative of the attributes of ride-hailing drivers in California, we developed a weighting procedure. One of the TNCs provided statistics on several variables of the population of drivers, and these were used as targets to perform iterative proportional fitting. This is a technique that iteratively updates an initial set of weights, with each iteration ideally making the weighted sample data more closely match the target distributions. And the table that you can see on this slide shows the root mean square error, which is a measure of the difference between the population and the sample distributions for unweighted and weighted data in the two survey waves. And as you can see, the weighting procedure reduced the RMSE significantly. That shows that it was successful in improving the representativeness of the sample. And based on this weighted data, I will next present some key statistics of the sample. First, here is the breakdown of the variables that were used in the stratified random sampling plan that Giovanni described. Our weighting procedure was intended to perfectly match the population distribution of weekly driving hours. So as you can see, the majority of drivers are occasional, but the small percentage of full-time drivers actually would generate the most vehicle miles in ride-hailing. Our stratified sampling and weighting procedures also enabled our sample to include drivers from regions of California with sparse ride-hailing activity, considering that most drivers are concentrated in the Bay Area and Southern California. And at the bottom here, you can see the final sample sizes used for the analyses that will be presented here and also are available to view in the report. Next, we can see some key attributes of drivers and compare them to the general adult population of California according to the American Community Survey, which is conducted by the U.S. Census Bureau. So relative to the California population, ride-hailing drivers in California are more likely to be aged between 35 and 54 years old, more likely to be male. There's also a large representation of Hispanic and Latino people in the ride-hailing driver population, and ride-hailing drivers also are more likely to be from a low-income household compared to the general adult population in California. And this is important to consider when you look at the cost difference between electric vehicles and gasoline vehicles, also the expenses to be paid on home charging infrastructure and things like that. On this next slide, we can see the distribution of drivers having one, two, or even three or more vehicles registered to use on a ride-hailing platform. So the vast majority of drivers use one vehicle for their ride-hailing activity. Then there are, around 9% that have two vehicles, and a very small number have three or more. And on the right, there's also the distribution of the types of vehicles that drivers use. With right now, the majority still driving gasoline vehicles, and then regular gasoline hybrids, so not plug-in, and battery electric vehicles then being the next most used vehicle for the primary vehicle used to provide ride-hailing services. Another thing to consider is that there is some variation in the type of vehicle that drivers use based on whether they obtain the vehicle with the intention to use it for ride hailing, or whether they decided to try ride hailing and then just picked from their existing household fleet. So this first case, we can see the first case would be with the intention, and the second case is without intention. So we can see that across both waves, drivers who registered a pre-existing household vehicle were more likely to drive a gasoline car for their primary vehicle. However, those who went out and picked a vehicle specifically to use for ride hailing were more likely to choose either a gasoline hybrid or, especially in the case of wave two, a battery electric vehicle. And our next presenter, Xiatian, will talk more detail about this and actually consider the factors that influence drivers' current use of different ride-hailing vehicle fuel types. So I'm going to pass it over now.
Thanks, James. So we will look at the fuel type choice of a driver's current vehicle using the only first wave of survey. Next slide, please. So let's start by looking at the key factors that influence drivers' choice of each registered vehicle. This figure represents their response to 5 most selected factors grouped by their fuel type. And within each fuel type, results are further grouped by ride-hailing intentions. As James previously explained, it refers to whether drivers obtain the vehicle with the intention to use it for ride-hailing work. As you can see, the bars that was highlighted using the red circle, fuel type and the fuel efficiencies are the most frequently selected factors, especially for hybrid and battery electric vehicles, and also among those with ride-hailing intention. This is expected since high fuel efficiency will help reduce drivers' operational costs. Interestingly, for BEVs, more than 1/3 of drivers also choose them in order to be eligible to provide upgraded ride-hailing services such as Uber Electric or Lyft Green in order to have higher earnings. Next slide, please. From these observations, we learned that the motivations of vehicle fuel type choices are quite different among different driver groups. This motivates us to run some statistical models to dive deeper into different factors. As you can see, we propose this nested structure. On the top layer, we learn which social demographic characteristics differentiate the driver between with or without intention. And then on the bottom layer, we try to learn what factors impact their fuel type choice and compare the differences between these two groups. I wanted to emphasize, however, in reality, these two choices could be and actually are likely to be made simultaneously, but we think this structure can better serve our purposes of identifying different groups. Next slide, please. We jointly model these two variables using an integrated choice and latent variable framework. The advantage of this model is to be able to identify the impact of both observables and latent factors such as attitudes and perceptions. As you can see, the structure for the intention utility, we propose the social demographic factors will help explain whether a driver will obtain the vehicle with or without intention. And then additional variables including TNC work schedules, attitudes, charging availabilities, and their familiarities with EV incentives are included in the model to predict their fuel type choice as the second utility shown here. Next slide. So following key findings from our model, drivers with ride-hailing intention are more likely to be socioeconomically disadvantaged. They are more likely to be older individuals, renters in multimodal housing, which usually provide lower access to EV chargers. They tend to have lower household vehicles, which means that they need more careful planning of their vehicle between ride-hailing driving and household use. And most importantly, they're more likely to rely on ride-hailing work as their primary income source. This may increase their instability of living. Next slide, please. Now let's move to factors that impact the vehicle fuel type choices. We find that attitudes and perceptions towards the electric vehicle plays a significant role. Those with favorable attitudes towards the economic and environmental impacts of EVs and those with high social norms of supporting EV use are more likely to adopt a BEV. On the contrary, those with high perceived barrier of BEVs are less likely to adopt the BEV. Those barriers include high purchase price, low driving range, the time spent to charge during their ride-hailing work. Next slide, please. Not surprisingly, EV charger access promote EV promotion, but its effect differ between two driver groups. Those with ride-hailing intention who tend to do full-time or intense driving are particularly benefit from public charger. As we mentioned before, this group is also more likely to live in multi-family housing with lower access to home charger. So public charger become their major source of charging. With comparison, those without the ride-hailing intention who tends to do part-time or occasional driving particularly benefit from home charger because they use their vehicle more for their household use. Next slide, please. We also find that EV incentive, especially federal incentives, including use or used EV tax credits and EV charger tax credits, promote BEV adoption. But as many of you know already, that unfortunately there have been those incentives have been discontinued or about to be canceled. But at least our study suggests that during the time of our study, those incentives are extremely important for TNC drivers. Next. BEV adoption is higher among vehicles leased or rented through TNC rental program. Those programs happening with other third-party companies, which provide drivers with more convenient and flexible access without the burden of ownership. Next slide, please. We can further measure the average effects of the key policy variables in a more intuitive way. As you can see the charts here, we still see significant gaps in terms of charger availability and the familiarity with incentives. However, as our model shows that they are significantly positively associated with the BEV adoption and are particularly relevant for policymakers, utility providers, and TNCs. So we can estimate each variable's effects, considering some hypothetical situations. If we're able to increase the charger availability or increase the familiarity and awareness of existing incentives, then how the share of vehicle fuel types among those TNC drivers will change. So here we see the intervention effects for chargers under 4 scenario compared to the basic scenario. The table on the left shows if we are able to improve the availability of public charger for drivers with ride-hailing intention, then we able to see that the decrease of ICEV and PHEV, HEV, while we see the significant increase of BEV. And then the tables on the right side shows the effects if we're able to improve the availability of home charger for drivers without the ride-hailing intention. Next slide, please. And this is the similar charts, but focus on the federal incentive. So overall, we see that improve of charger availability and increase the familiarity of incentives, increase BEV adoption, will reduce the share of other vehicles. I think this is encouraging from a climate and equity perspective because some policies, including public charging deployment and incentive outreach, would reduce the share of the most carbon-intensive vehicles in the ride-hailing fleets. Then, in terms of the magnitude of these effects, depends on whether drivers have the ride-hailing intention or not. They have different effects. We can see under every policy scenario, drivers acquiring a vehicle with ride-hailing intention exhibit a larger increase in BEV adoption than those without a ride-hailing intention. Therefore, it's critical for the electrification strategies to treat ride-hailing drivers as a heterogeneous group and provide different policy interventions. We will see more policy recommendations in the latter part of the presentation. With this, I will pass to my colleague. Thank you.
Thank you, Xiaotian. So I will now talk about the choice of the next ride-hailing vehicle for drivers, having just heard about the factors that influence drivers' current use of different types of vehicle. So first, this is the data that this particular analysis is based on. We asked the drivers a sequence of questions about their intention to add or replace a vehicle for ride-hailing, and then their willingness to consider different fuel types for their next vehicle if they have the intention to add or replace a vehicle. If the respondent selects either of the underlined options, they are asked this question, where they can then say whether they will definitely will not consider to definitely will consider along like a 5-point scale these different types of vehicle. And we're going to focus on drivers' intention to consider a battery electric vehicle for their next ride-hailing vehicle. Similar to the previous analysis presented, we have a statistical model that incorporates observable socio-demographic characteristics of drivers, attitudes and perceptions, and models both the intention to add or replace a ride-hailing vehicle, and for those who do have that intention, their willingness to consider an EV. We use a specific type of model called a Heckman type selection model that accounts for this two-stage decision process. Here's a summary of the results after estimating this model to find out the factors that influence both drivers' intention to add or replace a ride-hailing vehicle and their willingness to consider an EV. So you can see that drivers who have older ride-hailing vehicles that have experience with either a BEV before or a plug-in hybrid, and those who perceive chargers as being available and are familiar with incentives are all more likely to add or replace a vehicle for ride-hailing within the next year. On the other hand, if they own their current primary ride-hailing vehicle rather than rent or lease it, also if they are a homeowner, they are less likely to be adding or replacing a vehicle within the next year. Also, if they have already used a federal incentive at that time of the survey, they were less likely to add or replace the vehicle. Now, this shows that not only can these policies of investing in charging infrastructure and improving people's familiarity with incentives affect their choice of vehicle, it can also act sooner in the process to actually make drivers consider adding or replacing a vehicle. And then on the right, in the right-hand column, we find that those who are very familiar with federal incentives and those who have reserved home parking, so that indicates their potential ability to charge at home, for example, are more likely to consider getting an EV. And importantly, also the latent factors of subjective norm, which are a sort of social influence, can positively influence drivers to be willing to consider an EV, whereas perceived barriers make it less likely for them to consider an EV. And we're going to look at some of these factors in more detail in the next slides. So, for example, considering alternative scenarios where drivers perceive different levels of public charger as being available, what is the effect of these different perceptions of charger availability have on drivers' intention to add or replace a ride-hailing vehicle? We find that improving charging infrastructure can influence ride-hailing drivers' decision to update their vehicles. And by moving drivers from not knowing the type of chargers that might be available or perceiving no public chargers being available to at least a level 1 or level 2 charger can increase this probability by about 5% or more. Similarly, we can look at the effect of improving drivers' level of familiarity with incentives. Again, in this case, we're considering federal incentives, but as new incentives are developed to replace the discontinued federal tax credits, we hope to see a similar effect. So drivers with greater incentive familiarity are generally more likely to consider an EV. Importantly, those who are currently unfamiliar are less likely to consider an EV, even if they become more familiar with those incentives relative to those who already know something about these incentives. Now, this could pose a problem, and we need to consider these kinds of drivers carefully. But on a positive note, each improvement in familiarity up to being very familiar with the incentives increased the average probability of considering an EV by 15%, showing that this is a potentially powerful policy tool. Now, in these two studies that we've presented, we've talked about these latent factors, for example, subjective norm, which is a kind of social influence. These were measured in the survey by drivers' agreement with these statements. So, it's about whether people who are important to them think they should have an EV, the riders or, ride-hailing users' perceptions of EVs, whether they know other drivers who are considering them, and whether EVs are viewed favorably in the ride-hailing industry. So this analysis showed that drivers who are older and those who are not male tend to have less of this kind of social influence, whereas drivers who live in areas with greater population density and a greater share of EVs among registered vehicles in their residential location were actually more likely to experience this, positive social influence. And as you can see in the figure on the right, the more that there is this positive social influence, the more likely it is for a driver to consider an EV for their next vehicle. So the insights we can take from this is that it is important to connect older and non-male drivers to peers that have a positive evaluation of EVs to improve this like social influence, and also to target positive messaging regarding EVs at these driver groups. Similarly, we can look at the perceived barriers, which, as Xiatian explained, include like the high price of EVs, inadequate driving range, and the need for charging being a bit inconvenient. So there is this opposite effect where the less that drivers perceive barriers, the more likely they are to consider an EV for one's next ride-hailing vehicle. We also found that drivers who are from high-income households, occasional drivers, and those who have a high school education or below were more likely to perceive lower barriers to obtaining an EV. Now, this last finding about the education level, although perhaps counterintuitive, aligns with previous studies on taxi drivers and their intention to obtain an EV. So the insights we can take from this part of the analysis is the need to reduce the perceived barriers for low and moderate income and full-time drivers. Also, reducing these barriers may be less potent than increasing the social influence, which is an interesting consideration for policy interventions. Now, to conclude this presentation, I'm going to pass it over to Yongsung to talk about the summary and policy recommendations. Oh, Yongsung, you are muted.
Yeah, thanks. Thanks, James. And now I will share what we've learned about the early impacts of California's climate standard. Next slide, please. First, regarding BEV uptake, we are seeing that it is still limited, but there is growth. So our Wave 2 survey data shows that approximately 16% of ride-hail drivers now have at least one battery electric vehicles registered. Interestingly, BEV adoption is more common among full-time drivers and those who purchase vehicles specifically for ride-hailing. When it comes to charger access, we are seeing significant variation across the driver population. A major finding is that 55% of drivers report having no home charger access. This challenge is particularly acute for low-income drivers and those living in apartments or multifamily dwellings. On a positive note, we did observe that drivers' perception of public charger availability increased between our survey waves. One of our more concerning findings relates to incentive awareness. Only 7.4% of Wave 1 respondents had actually used federal EV incentives. Awareness was particularly low among low-income households, and state and local incentive programs were even less well-known than federal programs. This represents a significant barrier to adoption that needs to be addressed. However, there is promise when you look at driver attitudes. About 65% of drivers who are considering vehicle changes indicated that they would consider a BEV. Our analysis identified three key attitudinal factors that influence adoption decisions: positive attitudes toward EVs, social norms around EV use, and perceived barriers to adoption. Next slide, please. Based on these findings, we have identified several strategies to accelerate electrification in the ride-hailing sector. First and foremost, we need to expand and strategically locate charging infrastructure. This means targeting high ride-hailing demand areas to reduce deadheading and wasted time. Critically, we must address the disparities affecting drivers in rental properties and multifamily dwellings. our approach should differentiate solutions. To be specific, providing home chargers for drivers using personal vehicles and ensuring adequate public charging infrastructure for those using dedicated ride-hailing vehicles. Second, we need a multi-channel approach to increase incentive awareness. This should include partnering directly with transportation network companies to disseminate information to drivers. We need to specifically target low and moderate income drivers who are experiencing the greatest awareness gaps. This means leveraging social media, newsletters, and driver information programs, as well as engaging vehicle dealerships and retailers to actively promote state incentives at the point of purchase. Third, we should support mid-shift charging solutions. Many drivers need to charge during their work shifts, so we recommend developing charger location mapping tools and apps that aggregate information about all public charging stations. Policymakers could consider exclusive charging stations or discounted rates specifically for ride-hailing drivers. And importantly, charging location information should be integrated directly into TNC platforms where drivers are already spending their time. Next slide, please. Excuse me. As we look ahead, I want to acknowledge some limitations we need to address and outline our continuing research priorities. In terms of limitations, the one-year gap between our survey waves may be too short to fully capture behavior change, especially in a market where vehicle turnover takes time. We recognize the need for longer-term tracking as the CMS regulations mature and targets become more stringent. Our continuing research priorities include three main areas. First, we'll continue monitoring BEV adoption trends as CMS targets become more stringent over time. Second, we plan to evaluate the effectiveness of any incentive awareness campaigns that get implemented based on our recommendations. And third, we will assess the impact of new charging infrastructure investment on driver adoption and behavior. Finally, and perhaps most importantly, stakeholder collaboration will be essential moving forward. We need to consult directly with drivers about their preferred charging locations and timing. They're the experts on their own needs. We should partner with organizations that are already assisting drivers in making EV transitions. We need to work closely with TNCs to understand evolving opportunities and barriers as the market changes. And critically, we must coordinate across agencies such as CARB and CPUC to align infrastructure investments with incentive programs and create a coherent policy support for drivers. Next slide, please. We have a few academic studies and also project report out of this project. So please check these additional materials for more information. And now I want to conclude this presentation for today. So thank you for your attention. And we believe these findings provide a roadmap to accelerate electrification in California's ride-hailing sector while ensuring equity and accessibility for all drivers. Now we are happy to take your questions and explore opportunities for collaboration.
So thank you so much, Yongsung and all the team for the contribution. And I see that we have many questions already coming up in the question and answer tool. Joshua, I don't know which way. We have about 9 minutes, I think, so we can try to address as many as possible of them. We're also trying to answer some of them by typing, but also I would like to say on behalf of the research team, anybody that has any question and we don't have time to answer them today, feel free to contact us. You have the link here and the QR also to access our website. You can find a full page on the project. CARB has also posted the report on the page dedicated to this project, and the slides from this webinar will be also available. And we are happy to answer any question by email also, or also explore opportunities for collaboration, because we know that many people people in the audience might be doing very related work. And so there might be actually opportunities to collaborate also on related topics. So maybe
Yeah, Giovanni, I was going to suggest if you just want to start going through the questions that are in the Q&A, we're happy to read them for you, unless you just want to, for efficiency, read them yourself and answer with your team.
maybe I can suggest I can pick two questions related to data collection, and I can answer them right away. And then we have another one about modeling and analysis that the rest of the team can answer. So we have two questions somehow related. We can address them together. One was about the incentives that were used for the data collection, and the other one about in the stratified random sampling, we use one variable to measure the level of activity, the intensity of activity, how many hours the drivers were driving per week, and so how we created a threshold to divide the different categories. So for both these questions somehow related to the collaboration we had with the TNCs, we want to thank them once again. Uber and Lyft were particularly helpful, not only to help us recruit the drivers from their database or drivers registered on their platform, but also to somehow play with different level of incentives through some early pilot we did in the project that help us also assess response rates, number of respondents we would get under different type of incentive levels, and also better strategy for the recruitment of the respondents. So in particular, during that pilot, we tested several different approaches using different level of incentives. We, in general, use incentives in the form of gift card from a vendor or a retailer of the choice of the driver. So drivers could choose between 4 different retailers, as we've been doing in other studies too. In the past, we've been trying to test several different type of incentives in other studies at UC Davis. In this case, we would offer the option to get retailers from Starbucks. Somebody can get some free coffee for doing the survey, or Amazon buying something online, Walmart or Target. And so depending on the interest of the driver, they could choose the retailer of their choice. But we did test 3 different level of incentives because we wanted to understand the impact on the incentive on the response rate and also the best allocation of the limited resources when we do research with public money, that the limited number of resources how to best use for the project. And so we determined in the end that for a survey of this length, an incentive of $8 for the respondents that completed the survey was actually giving the compromise between the best response rate, but significant increase in response rate, while at the same time optimizing the resources that we could use for the project. An incentive level below that level would lead to much lower response rate. An incentive level above that level would not return any significant increase in the response rate, and so at that point will not be an efficient use of resources. For the question about the threshold used for the level of intensity of the driving, we actually work closely with the TNC providers, and we discuss with them, and we establish levels that were both functional in the terms of what does it mean to be at very high level of intensity for a driver or a supplemental driver, a driver that drives only part-time and so on, but also having threshold that would allow us to recruit enough respondents based on the population size, the group sizes in California, because we didn't want to set the threshold in a way that would be too difficult to recruit from groups that are too small. We have several other questions coming in. Maybe we can quickly go. Maybe James, you can take this one about how we control for the different type of behaviors for individuals that might have several confounding factors in the decision to choose which vehicle to get, and particularly an EV, if it is not acquired with the intention to drive for the ride hailing. And so other confounding factors in the choice versus separating drivers that have an intention to drive, and so the decision might be optimized for that purpose.
Yes, so the purpose of using these more complex statistical models like the integrated choice and latent variable model that Xiatian presented, and this 2-stage Heckman type selection model, also with some latent factors that I presented, is to try to control for these different kinds of variables that might be interacting with each other and influencing drivers' decisions. Now, we could only model the effects of the variables that we gathered data for from the survey. And also, it's not generally possible to include everything in a model. There's a balance between the simplicity or parsimony of a model in order to make it understandable and to be able to extract coherent insights from it, and then the power to investigate all of these different potential interactions of variables. And then a lot of that comes to, as the model is being built, investigating different specifications to see what actually best fits the data. And so we did find, influences of these latent factors. So things like drivers' attitudes, like the social influence, subjective norm, perceived barriers, um, and in turn, we also found that, drivers with different characteristics are more or less likely to have these kinds of attitudes. So, for example, the non-male and older drivers being less likely to have this positive social influence. So I hope that answers your question about how we addressed these concerns.
Giovanni, I think we have one participant who has raised their hands and would like to ask it directly. If we could take that one next. Natalie, do you want to help unmute them?
Yeah. Mariella Arceo, I'm not sure if I'm pronouncing that right, but I have unmuted your mic and hopefully you can ask your question.
I'm so sorry. I think I accidentally clicked the button.
That's okay.
That's super great information. Amazing findings, Richard.
Maybe Joshua, can I suggest? Oh, sorry. What's the question? No. So maybe Joshua, I can suggest there is a question that seems to be particularly relevant given that this is a webinar and a project carried out for a state agency for the California Resources Board in collaboration with the California Public Utility Commission. And there's a question about state versus federal incentives. If we can elaborate further about the different roles of these different incentives and also why the factor that make it one less impactful than the other one based on knowledge or impacts of particular policies and so on. James, I see you already typed the answer, but maybe it's useful also for the recording of the respondents to get the answer live. Maybe you want to take it?
Yes, okay. So yeah, in several of our analyses of the data, we did find a stronger effect of the familiarity with federal incentives than state incentives. So one thing is that it could have something to do with the data that we collected, considering that overall our sample of drivers were much more familiar with federal incentives, and there was a much smaller number of drivers who were familiar with any of the state incentives. Also, the most popular, or sorry, not popular, but the state incentive with which drivers were most familiar was the Clean Vehicle Rebate Program, which was actually also discontinued around the time, maybe shortly after we launched the survey. So, it could be an effect of just at least partially the differences in the familiarity that drivers have with the incentives. But then there are also other potential reasons. So, for example, the federal incentives consisted of tax credits for purchasing a new or used electric vehicle or charging infrastructure. There was no equivalent kind of tax credit incentive offered by the state, and drivers could just prefer this type of tax credit incentives to others, such as rebates. Then also we have to consider that in 2024, before the federal incentives were discontinued, and around the time that the survey was launched, the federal tax credits were actually improved in the sense that drivers could put the value towards the initial price of the car by transferring the tax credits to a dealership, therefore reducing the upfront costs of the car, making it more flexible for drivers to use, which would have made it a very attractive incentive. And that could also be why around the time of the survey, it was more influential than state incentives.
Great. Thank you, James. Giovanni, I think we'll need to end the questions at this point. I want to really thank the team for their presentation and for their exemplary research over the past 3 years. I'm very pleased they were given the opportunity to present it to the public today. Great to see so many folks attending. As you can see from Natalie's posts, the report is final and online, but we will be posting the slide presentation and the recording today in the coming weeks to the same website. So keep your eyes on that site. Thank you, everyone. Thank you, our team. Thank you, the Public Utilities Commission, and hopefully everyone learned something today. Thank you.
Thank you all.